Now coming to the next question, it's arrangement question. Arrange the following compounds in increasing order of their property indicated. First one is, these acids are given and you have to arrange them in the increasing order of acidic strength. You can see basically they are all derivatives of ethanoic acid. You know, it is CS3COOH is ethanoic acid. One H is taken out and we have put NO2 group. Then we have put fluorine. Then we have put cyanide. These are all electron withdrawing groups, but their electron withdrawing power is not same. Understand? The more, we have discussed before, the more the electron withdrawing power, more will be the polarity of the OH bond and more is the acidic strength. And what is the order here? Fluorine less than cyanide less than nitro group. It is there in your textbook. This is the increasing order of electron withdrawing power. More the withdrawing power, more the acidic strength. So this will be, that is, if I label this as 1, this as 2, and this as 3, suppose. Then what is the order? This fluoroethanoic acid will be weaker than, then comes cyanide, that is 3, then it will be less than nitroethanoic acid. So this will be the answer. There is an area in your textbook where these are given in increasing order of electron withdrawing nature. Learn that area well. This application is from that area. So this is the weakest, then comes this, and this is the strongest, increasing order. Now, next one, ethanol, propanol, butanol, propanone. Reactivity in nucleophilic addition reactions. We have studied in the same session that ketones are less reactive than aldehydes. And bulkier the group, more will be the hindrance and lesser will be the reactivity. So let us apply that here and find out. You know, these two are ketones. In butanone, one will be methyl, one will be ethyl. 1, 2, 3, 4. Butan 2 on. Propanone, one will be methyl, the other is also methyl. Both are methyl. So both are ketones. And when you come to ethanol, it is CS3, C double bond OH. Propanol is CS3 and this is C2H5. Let us compare the hindrances and the electronic reason. Ketones are less reactive. So these two will be less reactive than these two, which are aldehydes. But among these two ketones, this has more bulky groups versus this one. So butanone will be less than propanone. Okay. Then among propanol and ethanol, this is more bulky compared to ethanol, where there are only 2 methyl groups. So among them, propanol will be less than ethanol. It is also index question from your textbook. So what's the order? Butanol less than propanol. Less than propanol, less than methanol. I hope the concept is very clear to you. Next one, how can you convert each of the following into benzoic acid? These are, all the 3 are from index question area of your textbook, just taken from the textbook. First one, acetophenone to benzoic acid. So we are going to see how to do it for a revision. Acetophenone is benzene connected to COCS3. This is acetophenone. You know, it is side chain oxidation. Side chain oxidation, whether it is alkyl group or groups like this, you can do side chain oxidation using alkaline KMNO4 followed by hydrolysis. So we can use KMNO4, that is side chain oxidation. Register. KMNO4 KOH heat, alkaline KMNO heat. Then you will change this into COOK because we have used KOH. So it will change into COOK, but then you have to hydrolyze it. Then the COOK will change into COOH. The salt will undergo hydrolysis. So we are converting acetophenone to benzoic acid. And one more thing you have to practice in your board paper when you present your answer sheet. That is, whenever you do a conversion, it is always better to write. For example, here, they have asked you acetophenone to benzoic acid. So in the presentation area, here you write acetophenone. And here you write benzoic acid. It's a very good presentation. Clear? So practice by writing. Then the next question. Ethyl benzene to benzoic acid. Same thing. Because it is also side chain oxidation. I don't know why the concept is repeated, but it was how the question was given. Ethyl benzene, same thing. You are going to do the side chain oxidation. Same thing, KMNO4, then KOH, heat. You will get the potassium salt, COOK, hydrolysis. You will get benzoic acid. Here also, you will write below this ethyl benzene, below this benzoic acid. Clear? Presentation. Now, what's the third one? Bromobenzene to benzoic acid. That is different from the previous two. So let's see how to do it. Bromobenzene to benzoic acid. Here you have to think, it is also index question only, but let's see what's the application. Bromobenzene, you have to convert into benzoic acid. It is not side chain oxidation. You can see we are stepping up. You can see only 6 carbons here, but here there is an extra carbon, extra fitting of carbon in the side chain. That means 1 carbon more in the product formed compared to the parent compound, the starting material. So when you're stepping up, especially when you have a carboxylic acid, think about carbon dioxide route or cyanide route, all those things you know when you have done organic chemistry in detail beforehand. Okay. So here, because it is a halogen, you know, if it is cyanide, suppose you could change it into cyanide, then cyanide on hydrolysis, you can get benzoic acid, COOH. But converting Br into Cn, that is nucleophilic substitution of Br into Cn, it is not possible here due to partial double bond character. So that cyanide route will not work here. So the only thing what you can think about is carbon dioxide route. So what you have to do, we can convert this into Grignard reagent. And Grignard reagent will react with carbon dioxide, forming an adduct followed by hydrolysis. So show you how to do it. You take your bromobenzene, make it react with the magnesium in dry ether. You will get your Grignard reagent, phenyl magnesium bromide. Then make it react with carbon dioxide. That is, first you make it react with carbon dioxide, you will get an adduct. And that adduct is followed by hydrolysis. Then you will get benzoic acid. This is what you have to do. If you want to know the adduct, I'll just show you how to get the adduct also if you want to write. But in a conversion, this is enough. Okay, you don't have to show the adduct in a conversion. But if you want to do the conversion with adduct, how will you present it? It is MgBr, right? MgBr. You know, it is carbon dioxide is O double bond C double bond O, right? Here it is Mg onwards, it is plus. This carbon is minus. The CMg bond is like this. Then here, minus plus. So what you can do is, this plus you can connect here. Understand? Carbon dioxide plus you can connect here. Understand? So this will become MgBr, C double bond O MgBr. Understand? This will be the adduct form. Then you break it here. It will become H here, OH here. So you'll be getting benzoic acid and MgBr OH. But not at all compulsory to show the adduct in between. Understood, everyone? Clear. So we have completed this session. I hope all these questions are okay for you. You got the ideas properly and the applications properly. See you inside for the next session. And make sure to like, share, and subscribe to my channel, as I always tell you. And Also, make sure to watch all the other videos which I have uploaded in my channel. Okay, it will help you a lot.